In problem 3.1, a force of 20 Newton moves a body with an acceleration of 2 meter per second. So the force is 20 Newton. Acceleration acting on the body, that is 2 meter per second square. And we need to find the mass. So here we will use Newton's second law. Which says that net force is equals to mass into acceleration. So arranging for mass, it will be F net divided by A. F net is 20 and acceleration is 2. So it will become 10 kg. This is the required mass. In problem 3.2, the weight of the body is 147 Newton. And we are asked to find the value of mass. Here the acceleration will be equals to gravity, which is approximately equals to 10 meter per second square. So again, using Newton's second law, we can exchange this net force by weight, and acceleration will be replaced with gravity. So Newton's second law will be W is equals to mg. So to find mass, it will be W divided by g. It is 147 and this is 10. So it will become 14.7 kilogram. This is the required answer. Problem 3.3 says, how much force is needed to prevent a body of mass 10 kg? Mass is 10 kg and there is some object which is freely falling under the effect of gravity. So in this case, the acceleration will becomes equals to g, and we know that the value of g is constant, which is 10 meter per second square. So when the object is falling freely, the net force will becomes equals to its weight. So it means that we need to find the weight. Again, by using Newton's second law, I can change this law like W is equals to mg. I replaced net force with weight and acceleration with gravity. So to get the weight, it will be 10 multiplied by 10. 100 Newton is the required weight. Question 3.4, find the acceleration produced by a force of 100 Newton. So the force is given 100 Newton. Find the acceleration. So we are going to find acceleration, while the mass is also given, which is 50 kg. Simply using Newton's second law, F is equals to ma. So A will becomes equals to F divided by m. So F is 100 while mass is 50. So it will become 2 meter per second square. So this is the required answer. In problem 3.5, a body weight 20 Newton how much force is required to move it vertically upward with the acceleration of 2 meter per second square? It is asked to find the total force which is required to lift the object. So in this case, the weight of the object is 20 Newton, and we are lifting this object vertically upward with the acceleration of 2 meter per second square. So how much total force will be required? So for that, first we need to find the force which can produce this much acceleration, F. I suppose that is F1. So first I have to find the F1 force. So to find the F1 force, I am using the Newton's second law. But the problem is that we don't have the value of mass m in this law. M is missing. So to find m, I will use the formula of weight, that is W is equals to mg. So m will be equals to W divided by g. W is 20, while the gravity is as usual 10. So it will be, mass will be 2 kg. Now by putting this value here in Newton's second law to get the value of F1, so it will become 2 multiplied by 2. So F1 is equals to 4 Newton. So 4 Newton force will produce the acceleration of 2 meter per second. Now we will find the total force. The total force is sum of F1 and W. So I will write that the total force is the sum of weight plus the F1 force. So it is 20 plus 2. So the total force is 24 Newton. This is the required answer. In problem 3.6, two masses 52 kg and 48 kg are attached to the vertically frictionless pulley as shown in the figure. So the mass M1 is 52 kg while the mass M2 is 48 kg, and this M1 is accelerating downward while M2 is accelerating upward. So here we are going to find acceleration and tension in the string. We already derived the formulas for the acceleration and the tension, so I'm going to use those formulas. So for acceleration, it is m1 minus m2 divided by m1 plus m2 into g. So now I will simply put the values here. So it will become 52 minus 48, 52 plus 48 into 10 will be equals to 4 over 100 multiplied by 10. So the acceleration will be 4 divided by 10, which is 0.4 meter per second square. This is the required acceleration. To calculate tension in the string, the formula is 2m1 m2 g divided by m1 plus m2. So 2m1 is 52, 48, and the g is 10. So here it will be 100, while multiplying this it will be 104, and from here it is 480. So the tension will become equals to 400 Newton. In problem 3.7, again there are two objects, but now in this case the one object is at the horizontal surface while the other is vertically hanged. So m1 is 24, m2 is 26, and we are going to find acceleration and tension. The formula to find the acceleration, that is m1g divided by m1 plus m2 for this case only. So it will be 24 multiplied by 10 and 24 plus 26. So it will become 240 divided by 50. So by dividing, it is 24 divided by 5. So the acceleration will be equals to 4.8 meter per second square. Now to find tension in the string, the formula for the tension is m1 m2g divided by m1 plus m2. 24 multiplied by 26 multiplied by 10 divided by 24 plus 26. Here it will be 50, and by multiplying them we will get 6240, and by dividing it is 124.5 Newton. In problem 3.8, how much time is required to change 22 Newton into second momentum? So the momentum is 22 Newton second, while the force is also given, which is 20 Newton. We will find change in time. So according to Newton's second law, in terms of momentum, which says the net force is equals to change in momentum per unit change in time. So to get this, I will arrange. The momentum is 22, it is 20, so it will become 1.1 second. In problem 3.9, how much is the force of friction between the wooden block of mass 5 kg? The mass is 5 kg, and the coefficient of friction between the wooden block and the marble floor is 0.6. It has no unit because it is the ratio between the same quantities. So we will find the force of limiting friction. So the formula for the force of limiting friction is mu r, where r is the reaction force, which is equals to weight, and the weight is equals to mg. So I can write Fs is equals to mu mg. So I will put the values here. Mass is 5, mu is 0.6, and gravity is 10. So it will become 30 Newton. This is the required answer. In problem 3.10, how much centripetal force is needed to make the body of mass 0.5 kg to move in a circle? So the mass is given 0.5 kg body moving in the circle of radius 50 centimeter. I will convert it into meter by dividing 100. So it will be 0.5 meter, and the velocity is 3 meter per second. We are going to find the centripetal force. The formula for the centripetal force is mv square divided by r. Mass is 0.5, 3 square, and 0.5. So the centripetal force will become 9 Newton. This is the required answer.